Hi, welcome to the Algebra 2 final exam review solutions. I'm going to start with 51. I'm going to try and get all the way through 57. Who knows? I'm going to talk as fast as I can. If you don't understand, just slow down the video, pause it, and go back. I'll try not to be too annoying. But the first thing you have to know is for 51 through 54 is that they give you the functions up here in the instructions. F of x is 3x minus 5, and g of x is x squared plus 2. So for the first problem, 51, find f of g of negative 2. Well, this is going to be two steps. First, we're going to find what g of negative 2 is. So we look at the g function, put in negative 2 for x. So negative 2 squared plus 2. Negative 2 squared is 4 plus 2 gives you 8. And then we'll put 8 in to f of x. So put in 8 instead of x. So f of 8 equals 3 times 8, replacing the x with 8, minus 5. So 3 times 8 is 24. 25 minus 9 is 19. Okay, works for me. Now, 8 was what g of negative 2 is. So our final answer, f of g of negative 2, is 19. All right, 52. Backwards and with a 3. So g of f of x. So first we find out the value for f of 3, and then we put it into g. So f of 3. 3 times 3 minus 5. 3 times 3 is 9, minus 5 is 4. So f of 3 is 4. So g of f of 3 is actually going to be the same as g of 4, because f of 3 is the same as 4. Okay, so g of 4 equals, make that an arrow instead of equals, g is x squared plus 2. So 4 squared plus 2. 4 squared 16 plus 2 is 18. So g of f of 3 equals 18. All right, for number, there you go. There's all the work for 52 if you need it. Oh, nice and neat, I say. Okay, maybe I'm wrong. All right, 53 and 54, find the inverse functions. This would be a nice note to have on your final. To do inverse functions, on your final note sheet, remember you take x and you switch it with y, and then you solve for y. Okay, that's how you find the inverse of a function. Switch x and y and then solve for y. All right, so we're going to do that with f of x way up at the top. F of x equals 3x minus 5. The first step, I don't even have a y in here. I'm going to take out the f of x and just change it to y to make all the notation easier. Now, the first major step is swapping out the x's and y's. So y becomes x becomes y. All right, and the next step, just solve for y. So add 5 to both sides, equals 3y. Then divide both sides by 3 to get the y by itself. So y officially equals x plus 5 divided by 3. Well, the official notation is going to look more like this. F inverse of x equals x plus 5 over 3. And that should be the final answer for number 53. All right. 54. Find g of negative 1 of x. Well, if you look up here, right there, g of x equals x squared plus 2. Okay. So I'm going to do the same thing. I'm going to get rid of the g of x and just change it to y, just to make the notation easier. Then the next step is to switch x and y. So x equals y squared plus 2. And the last part of the problem is to get the y by itself. Solve for y, subtract 2 from both sides. X minus 2 equals y squared. Ooh, I need to get rid of the squared. So I'm going to take square root of both sides. So y is going to equal the square root of x minus 2. Now, putting back in the g of -1 of x. It's going to equal the square root of x minus 2. All right. And just so you know, because you can't take the square root of a negative, x is going to have to be greater than or equal to 2. That's a domain restriction. We talked about that a little bit. Okay, 55. Solving that equation. Move that into the spotlight. The cubed root of 5x minus 4 equals 2. First thing I need to do is cube both sides. Okay, so I get rid of that cube root. Send up with 5x minus 4 equals 2 cubed is 8. All right, now I just have to solve it for x. Add 4 to both sides. 5x equals 12. Divide by 5. Okay, 12/5 is your answer. If you want it as a decimal, you get 2.4. Either way is fine with me. Okay, so that's 55. 56. It's just a little stranger. All right, I'm going to have to wait on that because the bell's going to ring in like 2 minutes. So I'll do number 56 in the next video. Thank you. Have a good day. Make a really nice note sheet. Bring cookies.